The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to do our final review for the final exam, which is tomorrow. It needs to be finished, it needs to be finished no later than 11:59 p.m. tomorrow night. And with that, let's take your questions.
Okay, I have quite a few.
As I expected. Okay.
Okay, so chapter 6 test 10 and 13.
Okay. Chapter 6 test. Chapter 6 test 10 and 13, you said. Okay. Let's see here. Okay. So I can see what you didn't do. You didn't finish the problem. You factored it, but you didn't solve it. So this was what the chapter, hang on here, let's get the mouse there. This is the chapter 10 test, right? Oh no, chapter what?
6.
6, my bad.
Yeah.
Chapter 6 test, problem number 10. All right, so solve the equation, x squared minus 4 equals 0. And you factored it correctly, but you didn't solve it. So you'd go on and you'd say, well, x plus 2 equals 0, x minus 2 equals 0, subtract 2 from both sides, add 2 to both sides. So you get x equals -2, 2. Okay.
Okay.
So you were on the right track, you just didn't finish. And then what was the other one?
13.
Oh yeah, and this is something that I probably gave you credit for this one. Can you see your answer there?
Yeah.
You put a period instead of a comma.
Oh my God.
That's all it takes. That's all it takes.
I even looked over it and I was like, that's the right answer.
Yep. WebAssign does not think for itself. Yeah, and again, I'm sure that I saw that and gave you points for it, which is probably why there's an asterisk by your grade. Okay, what else? Anything else from this chapter?
I'm good on that chapter.
Okay. Anybody else want to look at chapter 6 while we're there? Okay. So we're going on to chapter 7, I assume?
Yeah.
Okay, give me a minute here. And the test?
Yep.
Okay, where do you want to start here?
So I'm going off the ones that I got wrong just to make sure that I'm getting them right. So number 1, I ended up getting 5 because I totally biffed that one, but it's 5 and -5.
Okay. So this is
negative.
This is the chapter 7 test. Number 1, find all real numbers for which the rational expression is undefined. Okay, so you've got 4x minus 11 over x squared minus 25. When would it be undefined? When you're dividing by 0. So when is that equal to 0? Well, if you factor it and solve it, you get those two values. So x is -5 and 5.
Okay.
All right. What's next?
4, 6, and 7.
Okay, and again, anybody else, if you have questions, jump in. Okay. All right, this is number 4. 7 over 6b squared minus 9 over 4b cubed. So we need a common denominator. 6b squared, 4b cubed. This is 2 times 3 times b squared. This is 2 times 2 times b cubed. So we need 2 squared times 3 times b cubed, or 12b cubed would be the common denominator. Any questions about how I found that?
No.
All right. So the first fraction we're going to multiply by 2b, which gives us 14b. The second fraction we're going to multiply by 3/3, which gives us 27. So we get 14b minus 27 over 12b cubed. Now, you could factor a 7 out of the top. No, you couldn't. 7 doesn't go
No,
into
it's the
27.
27.
My bad. Sorry. It's early
I tried
Monday.
doing the same thing earlier today. I just wanted to make sure I had the right answer.
Yep.
And then 6, I believe. Is it 6
6.
and 7?
You got 6 right. You see it there?
Yes.
You still want me to do it?
Yeah, because I think when I was doing it again today, I think I got confused, even though I got it right on the test.
Okay. Solve the equation and check the results. You know, your answers is a comma separated list, no solution, enter no solution, blah, blah, blah. Okay, so we got x plus 9 over x plus 3 plus 1 over x squared minus 5x minus 24 equals 1. So if we factor, let's see here, this denominator, we get the 2 factors below there. So our least common denominator is x plus 3 times x minus 8. Okay, so I'm going to multiply the left side of the equation by x plus 3 times x minus 8 and the right side by x plus 3 times x minus 8. So on the left side, distributing this times this, so you've got x plus 3 times x minus 8 times x plus 9 over x plus 3 plus x plus 3 times x minus 8 times 1 over x plus 3 times x minus 8 equals 1 times x plus 3 times x minus 8. Okay, so I just distributed the LCD. So far, so good?
Yeah.
All right, these cross out. So we've got x minus 8 times x plus 9. X minus 8 times x plus 9, which foiling, we get x squared plus 9x minus 8x minus 72. Combining like terms, x squared plus x minus 72. Okay, so all of that simplifies down to that. Next, this and this and this and this all reduce out, and we just get plus 1 equals, and over on the other side, we've got what? X squared minus 8x plus 3x minus 24, which is x squared minus 5x minus 24. Okay. On the left side, I can combine those two like terms. X squared plus x minus 71 equals x squared minus 5x minus 24. I know I'm moving kind of quickly here because I know you've got a lot of questions. Hopefully I didn't make any mistake. We'll find out. I'm going to subtract x squared from both sides. So now I've just got x minus 71 equals negative 5x minus 24. I'll add 5x to both sides, and I get 6x minus 71 equals negative 24. Add 71 to both sides, 6x equals, oh, what is that? 71 minus 24 is
Plus 24.
Oh, it's plus 24?
Or you could do 71. I thought you said negative 71.
So this 71 minus 24 is 47. Divide both sides by 6, x equals 47 over 6.
Okay.
Ta-da! Okay.
I forgot to add the LCD to the 1 on the right side.
Ah, yes. Common mistake.
Yes. Okay.
Mistakes are just common. They're just ordinary. I'm sorry. Okay.
And then
7?
7, yes, please.
Okay, and again, as I say, I'll just keep going along with Lindsay here unless somebody wants to look at something else, and then we'll look at that as well. So here's number 7. Solve the formula for the indicated variable 1 over x minus 1 over y equals 1 over z. Solve for x. Well, x is in the denominator. I need to get it in the numerator. I'm going to multiply both sides by the LCD, which is x, y, z. Little poem there. Okay. Distributing x, y, z times 1 over x minus x, y, z times 1 over y equals x, y, z times 1 over z. X, y, z times 1 over x, the x is reduced and we have y, z minus x, y, z times 1 over y, the y is reduced and we have minus x, z equals x, y, z times 1 over z, the z is reduced, so we've got x, y. We're trying to solve for x. So let's get all the terms with x on the same side of the equation. So I'm going to add x, z to both sides of the equation. I now have yz equals xy plus xz. And here's the ticket. We need to get x by itself. So what we're going to do is factor the x out of these two terms. Now I come back and divide both sides by y plus z, and I get x equals yz over y plus z. Any questions on that? Anybody? Okay, we ready to move on? Not quite. All right. Let us know when you're good to go, Lindsay.
Okay, I'm good to go for chapter 8.
Oh, okay. So, as in go to chapter 8, you mean? Or,
Yeah,
okay.
the test and
Yeah.
then 4.
Okay, chapter 8 test. And it looks like we're going to start with problem number 4.
Yeah.
Okay. All righty. So this is chapter 8, test number 4. In a proposal to some prospective clients, a housing contractor listed the following costs. Fees, permits, miscellaneous, $13,000. Construction per square foot, $70. Basically, the $13,000 is considered a fixed cost. That's a one-time cost. And the $70 is a variable cost because that depends on how many square feet. It says write a linear function that clients could use to determine the cost of building a home having F square feet. Okay. And it looks like you got the first part correct. Do you want me to go over that again or just you okay with that?
No, we can go to the second part.
Okay, so but your equation C of F equals 70F plus 13,000. It says find the cost of building a home having 1,770 square feet. So you want to find C of 1,770, which is 70 times 1,770 plus 13,000. So it's calculator time. 70 times 1,770, which is 123,900 plus 13,000, and that is 136,900.
Yeah, I don't know how I got that one wrong.
Yeah, I don't know either. Life is a mystery. Okay. Do you want to look at 5A?
Yes, please.
All right, G of -2. If we look at the graph, okay, G of -2, that's saying when the input or the X value is -2, what is the Y value? Well, on our graph, X is -2 is right there. if we go up and find the point on the graph, the y value is positive 2.
Okay.
All righty. Okay, number 9.
Yeah.
So absolute value equals absolute value. Got 4 times x minus, or 1 minus x plus 1 over 4. 5x minus 2 over 5. The first thing that I would do, just because it makes it a whole lot easier, is I would simplify what's inside of that absolute value. Okay, so let's do that. We're going to get 4 minus 4x plus 1 over 4, which is negative 4x plus 5 over 4. Okay, so all I did was distributed and combined like terms. So far, so good.
Yeah.
So now I'm going to take this and deal with that, and I'm going to copy that on the next page. Negative 4x plus 5. Negative 4x plus 5 all over 4 equals 5x minus 2 over 5. Okay, so now we've got 2 possible equations. The first one is what's inside equals what's inside. The second one is what's inside of 1 equals the opposite of what's inside the other. Okay.
Okay.
Now, the left equation, the least common denominator is 20. So I'm going to multiply both sides by 20. The 20 over 4 reduces to 5. The 20 over 5 reduces to 4. So now on the left side, I've got 5 times the quantity negative 4x plus 5, which is negative 20x plus 25. On the right side, 20x minus 8. Okay.
Okay.
I'm going to solve for x. I'll solve for x on the left. So I'm going to subtract 20x from both sides. Negative 40x plus 25 equals negative 8. I'm going to subtract 25 from both sides. Negative 40x equals negative 33. I'm going to divide both sides by negative 40, and x equals positive 33 over 40. Okay?
Okay.
On the right side, the right equation, I'm going to go ahead and I'm going to move this up here, but it's applied to the whole thing. So then distributing it, I get negative 5x plus 2 over 5. You okay with that?
Wait, what?
So I took the negative out in front.
Oh, okay. I see what you did. I see.
Okay, just to make it easier to deal with, I'm going to multiply both sides by 20 again. 20 over 4 is 5. 20 over 5 is 4. So I get negative 20x plus 25 equals negative 20x plus 8. Add 20x to both sides, and we get 25 equals 8. So there's your only solution.
And just a second.
Okay.
No, hold on. So that's a plus 8. Negative 40. X. Okay, I see what you did. That makes
Ready?
sense.
10. That's it. So is that it for chapter 8?
Yeah, that is for me.
Anybody else? Chapter 8? Okay, well, I'll just keep going unless somebody jumps in and says, hey, can we look at such and such? Otherwise, we'll have the Lindsay and Ben show. Okay, so now we're chapter 9, right?
Yeah. So number 9.
A famous Beatles song, number 9, number 9. You don't know that one, huh? It's okay.
No.
Probably not missing much. It was on the White Album, which of course now would be the White CD. Useless trivia, runneth amok. Okay, this is chapter, what are we on? 9?
Yep.
And this is number 9. Simplify the expression, all variables represent positive real numbers, write answers without using negative exponents. And it looks like you got everything right except the negative sign. So let's see what's going on here. Okay. That's into the 6th power there. To the negative 2/3. Okay. The first thing I'm going to do is I'm going to take that negative sign and attach it to the numerator. So it's going to become this. Are you okay with how I did that? Does that bring up any questions?
No, that's good.
Okay. Next thing I'm going to do is I'm going to rewrite it as the reciprocal raised to the positive 2/3 power. Okay. And there's more than one way to do these problems. This isn't like the only way. Tomorrow I might do it a different way, but you got to use those rules. Now I've got a product / quotient raised to an outside power. So I'm going to take that 2/3 exponent and attach it to each factor in the numerator and the denominator. Okay. Now we're going to take it a piece at a time. Let's take this piece. 125 to the 2/3 power is equal to 125 to the 1/3 power squared. In other words, I can take the power and the root and pull them apart and do them separately.
Okay.
125 to the 1/3 power, that's the cube root of 125, that's 5. And then that's squared, so that's 25. So the thing I've got circled there becomes 25. Any questions how I did this?
No.
Right. Next, into the 6th to the 2/3 would be into the 6 times 2/3, which is 12/3, which would be into the 4th.
Okay.
Now, negative 64 to the 2/3 power is negative 64 to the 1/3 power, and then that squared. What's the cube root of negative 64? It's negative 4, because negative 4 times negative 4 times negative 4 is negative 64. And then that squared would be 16. So in the process, again, like I say, you had everything right, but that negative sign, you would have gotten rid of it when you squared the negative 4.
Oh. Okay. Okay, we're good on that one.
Number 10.
Yep.
Okay, 1/16 x to the 12th, y to the 4th, all to the 3/4 power. So that's going to be 1 to the 3/4 power, x to the 12th to the 3/4 power, y to the 4th to the 3/4 power, over 16 to the 3/4 power. So very much like what we did in the previous problem, we've got a product / quotient raised to an outside power. So that outside power gets attached to each factor in the numerator and the denominator. Okay.
Okay.
Then again, we're going to take it one piece at a time. 1 to the 3/4 power is like 1 cubed to the 4th power, which is like 1 to the 4th, which is 1. Okay with that?
Yeah.
All right. So this, so now we've got 1, and then this x to the 12th to the 3/4 power is x to the 36/4 or x to the 9th. And we've got this, y to the 4th to the 3/4 power is y to the 12/4, which is y to the 3rd.
Okay, hold on just a second.
Sure.
I'm getting really confused. So go back to the y that we were just on. So y to the 4th and then y to the 3/4. How are we getting the 3 again?
Okay, it's not y to the 4th, y to the 3/4, it's y to the 4th to the 3/4.
Right.
So you're going to multiply the exponents. 4
So you're
times,
gonna- is 12 and then divide by 4?
yeah,
Okay, okay.
4 times 3/4, or you can just reduce it down to 3 in the first place. Okay with that?
Yeah.
Oh, I'm looking at your answer. I know what you did wrong. We'll talk about it here in a minute. Okay, you ready?
6, 9, 3. So with 16, since there's not a power, would you just do it to the 1 or would you?
Well, it's 16 to the 1/4 cubed because there is a power. I mean, initially you're not doing anything inside, but 16 to the 3/4 power. So you break it apart, do the root and then the power.
Okay.
16 to the 1/4 power is 2. 2 cubed is 8. All right. So you've got that answer. Now you could either write it like that, or that's supposed to be a y. Now, let's look at your answer. Get ready to be mad. What's wrong with your answer? I'll tell you what's wrong with your answer. It's semantics. The y cubed, okay?
Oh, shit.
You guys know.
Man.
Do you see that? And again, I probably caught that.
Oh, I
And,
didn't put it as the power.
yeah. So
Yeah.
you just didn't use the little, this button. Okay. And
So I
again,
basically got it right, but I don't remember how to do it. That's great.
yeah. And again, I look at everybody's wrong answers to look for things like that. And I looked at that and I thought, yeah, she knew what she was doing. She just didn't know what she was doing. Kind of thing.
I
But
didn't
yeah.
hit the button.
Right. Okay. Moving on here, we've got, let's see, 11, 12, 13. Okay.
14.
Oh, 13?
14.
14.
Yeah.
Okay, your answer, well, it's just not simplified. What's 28 divided by 7?
4.
So that's all you, yeah, okay?
13. Okay. So to take that one, like the first T, you would do T with the 1/8 and then parentheses and then a 7 on the outside, right? Like we just did with the Y.
Oh, in other words, how would I get from here to there?
Yeah,
Okay, let's see.
because I don't remember.
Let's take a look. Okay, number 14, t to the 8/7 times t to the 27 plus t to the -8/7. Okay, so distributing t to the 8/7 times t to the 27 plus t to the 8/7 times t to the -8/7. All right, multiplying two powers with the same base, you add the exponents. 8/7 plus 27 is 28/7. So this would be t to the 4th. 8/7 plus -8/7 is 0, and t to the 0 is 1. So t to the 4th plus 1. Again, you just didn't simplify the 28/7. Yeah. So what you've got is equivalent to the right answer. It's just not simplified completely.
Okay. I just kept it in that fraction form.
Yeah, yeah.
Okay.
17,
Yeah,
8 times the cube root of negative 81a cubed. Ah, okay. All you forgot to do was to take the negative out. Actually, there's more than that because then this would have. Yeah, oh, hang on.
they're just the negative.
Okay, all right. So negative 81 is negative 1 times 81, okay?
Mhm.
Which is negative 1 times 3 times 3 times 3 times 3, okay?
Okay,
Which is negative 1 times 3 cubed times 3.
Yeah.
And we've got this a cubed as well. So we've got 8 times the cube root of negative 1 times 3 cubed times 3 times a cubed. Okay,
yes.
so we've got an 8 outside. The cube root of negative 1 is negative 1 outside.
Okay,
The cube root of 3 cubed is 3 outside. The cube root of a cubed is a outside. So we've got negative 24a cube roots of 3.
Yep.
Good to go on?
Yeah.
19, h of t equals the square root of t squared plus t minus 11. And we're supposed to find h of negative 5. So that would be the square root of negative 5 squared plus negative 5 minus 11, which would be the square root of 25 minus 5 minus 11, which is the square root of 20 minus 11, which is the square root of 9, which is 3.
Okay.
All righty.
Yeah. Can we do B on that one for the undefined?
Oh, sorry, didn't see it. My bad. Okay, so h of negative 1 would be the square root of negative 1 squared plus negative 1 minus 11, which is the square root of 1 minus 1, oops, minus 11, which is the square root of negative 11. Yeah, now it wouldn't be negative 11, it would be the square root of negative 11.
But you can't have a negative square root, right?
Right.
Okay.
Can't take the square root of a negative number.
Right.
When we get done with this section, can
Yes.
we kind of just go over one-to-one functions? Like it doesn't have to be from 11.2, but just kind of go over
Yeah.
them.
Absolutely. You betcha. You betcha. And you remind me, okay? Jump back
Okay.
here and say, hey, don't forget this. Okay. So 21, the square root of 48 x squared over the square root of 8x squared y, which would be the square root of 48x squared over 8x squared y. Okay, I can put them together. This reduces down. 48 over 8 is 6 over 1. X squared over x squared is 1 over 1. So I've got the square root of 6 over y. Okay,
Okay.
which is equal to the square root of 6 over the square root of y. To rationalize the denominator, we'll multiply by the square root of y over the square root of y, which gives us the square root of 6y over y.
Okay. We're good.
Okay, let's see.
Then on to 10.
Okay, and we're going to jump to chapter 11, right? Gianna, is that it? Gianna?
Yeah, the 11.2.
Okay, and then we'll come back to 10, but 11, so 11.2, give me just a minute here.
Very good.
Let's see here. 3 hours later. Okay. Other class. Here we go. 11.2, you said.
Yeah, it's like question. Oh, I totally lost my thing. Question like 9 on, and it's just one-to-one functions. I just kind of like want to remember them.
Sure. Okay. So this, oh yeah, this is 11.2. So number 9 says determine whether the function is 1-to-1. All right. I would say something like this, probably be easiest just to visualize it or graph it. This is f of x equals 8x, right?
Mhm.
Okay, which is y equals 8x. Okay, and what does that look like? Well, that's what looks kind of like that because it has a, oops, it goes through the origin and has a slope of 8. So it's a linear equation. You follow what I'm saying?
Yeah.
And is that 1-to-1? Yeah.
Okay. Awesome.
Now let's take a look at 10 though. Number 10, f of x equals -x squared minus 3x. Okay, so what is that? Well, that's a parabola, right? It's a second degree equation. And the leading coefficient, a, is negative. So the graph of that thing is going to look like that. Okay.
Okay.
Now, is that 1-to-1?
No.
Yeah, it is. Oh, wait, no, it's not. My bad. My
Oh, I
bad.
was like, oh, hold on.
No, no,
It does.
sorry. I was thinking function, not one. Plus, I'm being distracted because somebody's calling me and I'm trying to ignore the phone.
Okay.
Over there. Sorry. Yeah, it doesn't pass the horizontal line test. My bad. So it's not a function. And it's not a 1-to-1 function. Ah, that phone is so annoying. People call me during class and sometimes, and it's like, well, they don't know. But anyway, I just take my phone and throw it in the other room or something. Okay. All right, let's go back. So this is a function and it's 1-to-1. This is a function, but it is not 1-to-1. Okay.
Okay.
All right, now let's take a look at 11. Here we go. Determine whether the function is 1-to-1. Okay, if it's 1-to-1, for each x, there is only one y. And for each y, there is only one x. Well, let's see. We've got 2 different x's, 4 different x's going to the same y. So yes, it's a function, but it's not 1-to-1 because you've got more than one x going to the same y. It's got to be just a 1-to-1 correspondence, 1x to 1y. Each y comes from only one x. That making sense?
Yeah.
Okay. Here, use the horizontal line test to decide whether the function is 1-to-1. Yes, it is. Those are supposed to be horizontal lines I'm drawing.
It's okay. I see it.
Okay.
Okay. Awesome. Yeah. I think I just needed to like,
Sure.
I don't know. For some reason, I kind of just forgot.
I gotcha. Here, this is a function, but it's not 1-to-1. It fails the horizontal line test.
No.
This one passes the horizontal line test.
Greta.
Okay. Follow?
Yeah.
This is not 1-to-1.
Okay.
Is that it or more? Or what?
Yeah, that's it. No, I totally get it now.
Okay. Anything else before we go back to Lindsay?
No, you can go back to hers.
Okay, and Lindsay, what chapter are we on?
10.
10? Okay. All right, hang on
2 and 12.
just a second here, Lindsay. Where are you? Okay. Fine. There we go. All right, which chapter was it again? 10?
10.
Okay. Come on, chapter 10. 2 and 12. Okay. So this is the chapter 10 test number 2. Solve the equation using the square root property. It looks like you got your signs backwards. Okay.
Yep.
T plus 2 squared equals 25. It's already set up perfectly to use the square root property. So the square root of the quantity t plus 2 squared equals plus or minus the square root of 25. Okay.
Yeah.
So then t plus 2 equals plus or minus 5. Subtracting 2 from both sides, t equals -2 plus or minus 5. So t equals -2 plus 5, which is 3. T equals -2 minus 5, which is -7. So t equals -7, comma 3.
Okay. And then 12.
12, okay. The fireworks shell is shot straight up with an initial velocity of 120 feet per second. Its height s after g seconds is given by the equation s equals 120t minus 16t squared. If the shell is designed to explode when it reaches its maximum height, how long after being fired and at what height will the fireworks appear in the sky? All right, first of all, let's rewrite the equation so that it's in the correct form. Okay. So A is -16 and B is 120. This is a parabola opening downwards. So here's the flight. The shell is shot upwards and then it comes back down and it wants to explode at its maximum height, which is the vertex. So basically we want to find the vertex of this parabola, which is going to be at t comma s. All right, the correct ones. So x equals -b over 2a. Technically, it's t equals -b over 2a, but that's going to be what? -120 over 2 times -16, which is -120 over -32, which is 3.75. Okay. So that's the time it takes for the shell to get to the maximum height. You
Okay.
okay with that?
Yep.
Then it says what and at what height will the fireworks appear in the sky? So we need the S value. So basically we need to put in 3.75 for T. And when we do that, we get 225 feet by doing the calculation there. How did I do that so quickly? I cheated and just looked at the answer. That's how I did it. Okay with that?
I'm good.
That's it for that chapter.
Yeah.
Do you have anything from 11?
No, we already went over those ones.
Okay. Anybody else? Anything else? All right. Well, thanks for joining me all quarter. I hope you do well on your final tomorrow. Again, reminder, I will email everybody the grades personally once I have them corrected. So you can send me all the emails you want begging for the grades. I'm not going to send any out until I've got them all done and posted. It should be, let's see, tomorrow, Wednesday. I've still got to correct all the math 50 or math 85 finals that they took yesterday. I have to have them done by Friday. I definitely will have them by then, and maybe earlier. It just depends on how soon I get them all done. But anyway, it's been a pleasure being with you this quarter, and I hope you do well. I'll go ahead and stop the recording now if I can find the right button. And